All right, we're giving ourselves a little table here. You can kind of see this is the table here to the left, and it's the age of population in a small town. Now you can see the age groups are broken up, some interesting breakups, but it is what it is. So we're going to answer 3 questions on this first page, and the first one is, what is the total under 15 population? Well, notice under 15 would be these two, right? Under 5 and then 5 to 15. So we just add these two together, and when I do that, I get 2125. But that's not the total population, because remember, the table is in thousands. And because of that small detail, I need to go ahead and add 3 more zeros onto the end, because thousands means 3. So the total under 15 population is 2,125,000. Next, what about the 15 to 64? This actually should be 16 to 6, whatever. Okay, so now we're talking about this group here. So I add those two together, and when I add them together, I get 9,383, and again, I add 3 zeros. This should actually say 5 to 14, and then that would work. Anyway, 9,383,000. 65 and over, well, that's these two groups, so again, I add them together. 2,690. In thousands, we add 3 more zeros. So make sure you're paying attention to the fine print when you're dealing with these. Now let's go one step further. What is the ratio of under 15 to the total population? And again, let's pretend that's a 4. So under 15, we know if we add these two together, we get 2125. To the total population, well, the total would be if I add all of these together. When I add them all together, I get 14,198. So we're going to divide 2125 by 14,198. And you might be saying, well, Becky, you didn't put those 3 zeros on the end. And you're right, I didn't. But if I have a fraction, and it's any fraction, let's just say I have 9,000 over 12,000. Any fraction, that if they both have 3 zeros, those 3 zeros are just going to cancel out. So because my numerator and my denominator are both in thousands, they'll simply cancel, and it's okay if I just cancel them out. So now when I divide that, I end up with, I'm going to round to the nearest thousandths, 0.150. There we go. And this is a, oops, that's an R. This is a part to whole ratio. And we know it's part to whole because we are comparing to the total population, or the whole population. Let's take that a step further. So we know that our ratio that we just found is 150 thousandths. You know, that's over 1, right? You can make any number a fraction by putting it over 1. Well, here, this says, what if we want to compare it to 1,000 people? So instead of having this be a 1 on the bottom, we want it to be a 1,000. Well, that means we want to move our decimal 3 places to the right, because that will make this 1,000. Well, if I move my decimal 3 places in my denominator, I need to move it 3 places in my numerator, and that gives me 150. So there are 150 people under the age of 15 for every 1,000 people in this group. Now, it works the same on this next one. If I started with 150 thousandths and I want to go to 100,000, now I need to move my decimal 5 places, because there's 5 zeros there. So if I go 5 places, now I have 15,000 people under the age of 15 for every 100,000 people. So you really just have to pay attention. You know, your original ratio is compared to 1. So if you want to compare it to a different value, think about how that changes your denominator. And then last but not least, what percent of the total population is child dependent? Well, if the total population is, 150 thousandths, because this is part to whole, we can write this as a percent. So what percent? Well, percent is out of 100, so this is 15%. I just move it 2 places.